The Lord of the Rings, the Oscar-winning franchise that everyone loves. Yeah, those movies are great. So, obviously, they made more. Because you can't have enough of a good thing, right? Yeah, so The Hobbit, the red-headed stepchild of the Lord of the Rings franchise. The three movies draw heavily from the Lord of the Rings. They have Gandalf in his pre-white supremacist years, they have mid-2000 CG monsters, and everyone's favorite shield surfing, hard drinking, and animal abusing elf, Legolas. Everyone loves Lego, as the cool kids call him, so much so that they brought him back, despite not being in the book at all. So, the return of Legolas also marks the return of physics-defying stunts. So let's see what we got this time. Here we see Legolas is fighting an orc called Bolg on top of a crumbling tower that is hanging on top of a chasm. When... Now, you might think that that looks stupid, but that is only because of how stupid that looks. Let's see it again. Now, I have to ask, is this really stupid? Oh yes. Yes, it is. But is it physically possible? Theoretically, yes, but not really likely though. Now, what is happening here? The bridge collapses and Legolas goes with it, so he jumps on each rock in order to reach the other side. What he needs to do is push off from the block to reach the next block, and then do that a bunch of other times. So what we would need to know first is the momentum of Lego and the rock, and the Lego's momentum after he jumps. To find the momentum, we need the mass and velocity of the rock and Lego. I estimate that the rock weighs around 100 kilos, because that is a nice round number to do math with. Orlando Bloom weighs around 77 kilos. Is it creepy that I know that, you ask? No. It's science. Assuming both of them fall for 0.5 seconds, their velocity would be 4.9 meters per second. Using those numbers, we find their momentum, which we then use to find the net force on the rock, using the formula Fnet equals the change of momentum over time, which I totally didn't look up on the internet. So, we use that value to find the force of the push that Lego would have to make. After doing all that science, we find out that Lego would have to use a force of 8,891 newtons in order to move 1 meter in 0.2 seconds to the next rock. Now, that is a lot of force. It's not like jumping with two pianos strapped to your back while Billy Joel and Ella John play on them. Can Lego do that like 12 times in a row? I don't know. He is an elf. For all I know, he is also a vampire who shoots laser beams out of his eyes. But can a human do it? Well, Captain America could, but your average person, I honestly doubt it. Your average person might be able to do this if, say, they were standing on solid ground, but since they're not, they wouldn't be able to. So kids, if you have to fight a CGI orc somewhere, please do avoid collapsing towers in the middle of chasms. That's just unsafe. Unless you're an elf, in which case, I guess, go nuts.